In this problem, we're given several possible functions. Which of the following actually represent valid functions? By the way, if something isn't known to be a function, you can always call it a relation. So my job is to find out which of these four relations actually represents a function. The definition of a function is that for any given input, there is exactly one output, indicating there needs to be one and only one. So for example, on this first problem, I see that the input -3 has one output, -5. So I go through the following points to make sure that there isn't another point saying that -3 has some other output. The only other point I see that has an x value -3 is right here, but this is okay because it has the same output as before. So if someone asked me what happens when you plug in -3 as an input, I would say distinctly that you get out one output, and that's -5. The fact that they're listed twice is irrelevant in this problem. Continuing through, here is an input, 2, that has only one output. And mind you, I don't really care about what the output is, only how many there are. If you plug in 2, you only get one answer out. That's 3. If you plug in 6, the only output is 4. And if you plug in 12, the only output is 11. So I'm going to say that this is a function. In the next problem, you'll see that it's a function as well. Every input has only one output. Here, -2 only goes to one output. There's no other points that sends -2 to any other output. The input 1 goes to 3. There's no other points with an x value of 1. Here we have an x value of 4. It says the output's 5. There's only 1 there. The input 9 only has one output, and the input 15 has only one output. None of my x's repeat, so this is definitely going to be a function. In the third example, we have an issue. I can tell you right away this is not a function. If I was to ask somebody, or someone asked me, what happens when you plug in 3, I would have two answers. This point says that if you plug in 3, the output's 2. And this point says that if you plug in 3, the output's 5. So if somebody asked me what's going to happen if I plug 3 into this function g, I would say the output's going to be 2 and the output's going to be 5. Now that's a nice relation, but it does not fit the definition of a function. So I'm not going to check that one. My job is to pick the ones that are functions. The last set of ordered pairs, let's look carefully. The input's -2. It says the output's -3. I don't see any other points sending the input -2 to some other number. Likewise, the input of 2 only has one output, namely 3. The input 5 only has one output, namely 6. This point says that 9 will have an output of 8. I don't see any other points sending 9 to any other numbers. And then finally, the final ordered pair says that if you plug in 16, you get only one number, and that's 11. So I'm going to say that this relation is a valid function.